Hi folks. Today we're actually going to deal with the big question in calculus. What is a tangent slope? So we looked at this example the other day and we tried to figure out the rise and run when we wanted to find the steepness of the tangent at x equals 2 on just a basic parabola. So here it was, that's the real slope of the tangent. We tried to use a secant, but that wasn't quite good enough. It gave us a slightly different slope. And when we used the same point twice, we got 0 over 0, which at this point looks pretty fishy, because 0 over 0, when that happens at a limit, we say, oh, maybe there's fancy stuff we can do. And so today we're going to revisit that idea. This is called differentiation from first principles. We'll define these terms as we go through. But limits have given us a way around division by 0. We can't just ignore the fact that we have division by 0, but we can answer the question, what would it have been if we could divide by 0, sometimes at least. We can now revisit our earlier problem, which we were just talking about, of finding the slope of the tangent, where, say, x equals 2 on a basic parabola. Okay. So we're going to consider a couple of points here. We're going to consider the point 2, and I know that you could say that its y value is 4, but let's just call it f of 2. That's the y value, is what you get when you plug in 2 into the function. Yeah, it'll be 4 in this case. Okay, so there's one of the points we'll consider, 2 and f of 2. Then we're going to consider another point that's a little bit away from it. Let's call it 2 plus h, where h is the horizontal distance between these points. So essentially it's the run between these points. And I'm going to do this in a different color. And I'm going to have this point right here. Now that is the point 2 plus h for our x. And for our y, it would be f of 2 plus h. And what we do, if we wanted to find the slope between those points, and this would be a secant slope, but it looks pretty good, is we do rise over run. So our points are 2 f of 2 and 2 plus h, f of 2 plus h. They're just x and y for 2 points. Okay, the slope of the secant between them, I'm going to change colors just so it's easier to see. Slope of the secant is going to be y2, or f of 2 plus h, minus y1, which would be f of 2. Okay, so if we were to label these, here would be x1, y1, x2, y2. We know slope is delta y over delta x, or y2 minus y1 all over x2 minus x1. So I'm just plugging in literally grade 10 slope formula. And then on the bottom, I would have x2, which is 2 plus h, minus x1, which is 2. And that simplifies a little bit. Okay. And depending on how big that horizontal distance is, we'll get a secant that's either real close to 2 or that's farther away. So the slope of the secant line could be found using this. That seems pretty abstract. But what if we kind of started to move that 2 plus h closer and closer together? Let's think about how big we'd really like h to be. We can't make h 0 because then we'd have division by 0, but we could think about making h infinitesimally small. In order to find the slope of the tangent line, we need to make these points infinitely close together. In other words, the slope of the tangent comes from applying the limit as h gets infinitely small, as h tends towards 0, to the secant formula from the last page. So I'm going to put on those 2 points again. I'm just going to make them look closer together. And once we have those points, we'd still have a secant slope. But what if we just squeeze that h to be smaller and smaller so that this point right here gets closer and closer, infinitesimally close to the 2? Then what we'd have is the same slope as we had before. So let's see. It was f of 2 plus h, y2, minus y1, f of 2, all over. We already showed that it's going to be 2 plus h minus 2, so it'll just be all over h. That would be the secant slope right there. If we want to turn it into a tangent slope, all we need is one little sleight of hand. The limit as h goes to 0. That's going to give us the slope of the tangent at x equals 2. There we go. That's really all there is to it for finding a tangent slope. Now I have to go off to the side and do a little bit of work. I have to figure out what f of 2 is. Okay, so remember that this curve here is x squared. So 2 squared would be 4. F of 2 plus h is a little more work. It's going to be 2 plus h all squared. And when we square a binomial, remember we have to FOIL it by itself. So we end up with 4 plus 4h plus h squared. We end up with a bit of a mess because we've inserted this variable or this thing that's moving of h. But now that I know that, I can just sub those in. So I'm going to do this one in red. So let's find this slope. It's the limit as h goes to 0 of f of 2 plus h. We just found that down here. That's 4 plus 4h plus h squared. F of 2, okay, that's this thing right here. So minus f of 2, that's 4. Now that still looks bad. We can't sub in 0 for h because we'd be dividing by 0. But let's see if there's fancy stuff we can do. You might notice on top the 4's and the negative 4 add to 0. So we get 4h plus h squared all over h. And I really should factor this before I start dividing out. Because you don't divide out term by term. You divide out by factors. So there's a greatest common factor of h on top. Oh my gosh. And now it's looking good. I have the limit as h goes to 0 of 4 plus h. And as h goes to 0, 4 plus h is just going to be 4 plus 0, or 4. There is that tangent slope at x equals 2, okay, or that tangent gradient. If we think back to earlier when we tried using points that were closer and closer to the number 2 for the x value, like we used 2 and 2.1 or 2 and 2.01, we got numbers that were closing in on 4, just numerically. But you could always pick a number that was closer to it. By using a limit, we found the closest possible number to 2. So we have 2 points, but they're infinitely close together. Let's take that idea and generalize a little bit. So if you want the tangent slope at some point on a curve, let's say at this point A. So you have a point A, f of A. And then you have some other point, a plus h, okay, and f of a plus h. That would be its y value, just by subbing into the function. And that would give you the secant slope if you use those 2 points. But the slope of the tangent at x equals a, whatever that a value is going to be the limit as h goes to 0 of f of a plus h minus f of a, just rise, over run. We're making that h as small as possible. That is the underpinnings of all differential calculus. Now we'll have a slightly different way of looking at it in the end. We'll have a slightly more elegant formula. But this is really it, the big idea. You make 2 points as close together as you can, and that allows you to get around division by 0. You use the idea of a secant that's infinitely close together to find the slope of a tangent. The rest of this video will hinge around just practicing that technique. So we're going to find the slope on a bunch of different lines, or sorry, on a bunch of different curves. The first one is this function over here. F of x is 3x plus 4. We want to do it at x equals negative 3. So that's like our a value, if you want to think of it that way. So what does this formula need? It needs f of a plus h and f of a. So let's do the second one first. I'll try and color code this a little bit. So we'll find f of a. So that's negative 3. Okay, that's easy to plug negative 3 into this function. We'll get 3 times negative 3 plus 4, or negative 9 plus 4, or negative 5. That's what's going to go in for this part. The other thing I need to figure out is f of negative 3 plus h. Okay, so that'll be All I'm doing is subbing in this thing right here for x. Sometimes people get confused about that, so let's just go off to the side for a second on a different kind of tangent. If I asked you for f of 2, you'd know I put 2 in for x and you'd work it out. If I told you f of 5, you'd know to put in 5 for x and work it out, and we get 19. If I told you to put in pi, you'd put in pi. You'd get something. If we had to put in e, you'd put in e. If we said f of a sailboat, well, that's just what we'd put in for x. Whatever we're saying over here in these brackets, that's what we're putting in for x. Okay, so in this one, we're going to go 3 and then times negative 3 plus h, because that's what the function is being evaluated at, plus 4. And we'll just simplify a little bit. 3 times negative 3 is negative 9. 3 times h is 3h. This is this variable we've sort of inserted in here to talk about the horizontal distance. And so we get negative 5 plus 3h. And that's going to go in for this expression. So I'm going to take a second and just write that what we're looking for is the slope of the tangent at x equals negative 3. That means we're going to need the limit as h goes to 0 of f of negative 3 plus h minus f of negative 3. That's like our a value, all over h. At this point, we just sub them in. So in red, I have this f of negative 3 plus h, so that is negative 5 plus 3h. And then in green, I have this f of negative 3, okay, which is negative 5. Now careful here. It's minus whatever this is, so it's minus negative 5. Let's work this out. That'll give us lim as h goes to 0 of negative 5 plus 3h plus 5. Oh my gosh, those 5's on the top add to 0. So we're left with 3h over h. The h's can cross out because h isn't 0. It's just real close to 0. And we get the lim as h goes to 0 of 3. Well, 3 is always just 3. So in the end, our slope of our tangent at x equals negative 3 is just 3. Yay, we did it! Now, maybe at the start of this, you already knew that the slope was going to be 3. Because look at this function. It's a line. Its slope is always 3. So this is probably the world's worst way to show that the slope of a line is 3. But it's a good way to get into the technique of just subbing in. It's a linear, so it's not that bad. Let's use it to find the slope of something where the steepness is in flux. So we want the slope of the line tangent to this curve. And we know that this curve looks like a parabola moved down to at x equals 3. If I draw it, I know it should be pretty steep, and it'll have a positive slope. So again, sort of our a value is whatever this is, if you want to call it an a value. But what it means is that if we want the slope of the tangent at x equals 3, it's going to be lim as h goes to 0 of, the general form is f of a plus h, but in this case it'll be f of 3 plus h minus f of 3 all over h. And we just plug and chug in that formula. So let's figure out what f of 3 is, because that one's easier. It would be 4 times 3 squared minus 2. Or 4 times 9 is 36 minus 2, or 34. That's what's going to go in for f of 3. The other thing we have to find is more of a pain. And so there's some unpleasant algebra that we're going to have to do here. 4 times 3 plus h all squared minus 2. Okay, so I'm going to do my exponents first. I know this will multiply out to 9 plus 6h plus h squared. But if you're not sure, head over to the side, work it out by foiling it out. You'll get that 9 plus 6h plus h squared. And then there's still the minus 2 at the end. Okay, so notice all that I did in this first step right here is I put 3 plus h in for x, because that's what it told me to do. Keep on working it through. That's 36 plus 24h plus 4h squared. You can see how you might make some silly little mistakes here. So we have to be careful. 34 plus 24h plus 4h squared. Okay, that's going to go in for f of 3 plus h. I really like doing this work off to the side because then all the grunt work is done. I can go ahead and just sub it in. Okay, so for f of 3 plus h, I'm saying it's 34 plus 24h plus 4h squared. And for the other one, f of 3 is just 34. And I'm leaving my limit here because I haven't subbed in for h yet. I can't because that would be division by 0. But those 34s are going to add to 0. And we still have over h. If I want to cancel out, I got to factor. Now, it's true I could factor out 4h on the top, but I would be inclined just to take out the h that I need to get rid of. And then, finally, at this point, our problem disappears. Okay, so we're left with lim as h goes to 0 of 24 plus 4h. Or 24 plus 4 times 0, because we can sub in now. Or 24. That is the slope of that curve at x equals 3. And it's like we expected. It's a steep, positive slope. This one I want to leave you with as practice. So you could just pause the video, and this will kind of be your homework on this stuff. I will also put the solutions in here, but I think it's better if you try this yourself and then maybe check the solutions at the end. Okay, so I hope this has been helpful. Good luck with the material, and take care, folks. Now that my standard sign-off is done, and I assume that you've tried the questions, here we go. I'm going to think of this as f of x instead of y. So for this first one, I'm going to need to figure out f of negative 3, which would be negative 3 times negative 3 squared plus 2 times negative 3 minus negative 3 minus 5. Oh my gosh. I gotta tell you, this does not seem pleasant to me either. So if you're not enjoying this particular portion of it, you're not alone. Negative 38. And now I gotta figure out f of negative 3 plus h, which is even worse. So let's set this up. Negative 3 plus h all squared plus 2 times negative 3 plus h minus 5. Okay, and then we're going to multiply that out. So if you foil that all out, you'll get 9 minus 6h plus h squared. Do not just square each term. Minus 6 plus 2h minus 5, because I'm just distributing this through. Okay, and then that's going to give me negative 27 plus 18h minus 13h squared minus 6 plus 2h minus 5. Okay, so that's going to give me negative 38 plus 20h minus 3h squared. Yeesh, that's a lot of stuff to do. And you might be able to tell, if you get a keen eye, which number is really going to be in charge here for the final slope. Anyways, we're going to do slope of the tangent now at x equals negative 3. That would be lim as h goes to 0 of f of negative 3 plus h minus f of negative 3 all over h. Let's keep going. Limit as h goes to 0 of negative 38 plus 20h minus 3h squared minus negative 38, because that's what f of negative 3 was. Okay, at this point, the negative 38 and the essentially positive 38 here are going to cross out, or they'll add to 0. We get 20h minus 3h squared all over h. We're going to factor, and we're going to see what we get. So there's our h's. They can divide out. Gives us lim as h goes to 0 of 20 minus 3h. Now I can sub in. So I get rid of my limit because I'm actually substituting in. And the answer here is 20. Yay! That's a lot of work. And a lot of places to make silly mistakes. If you didn't end up with a negative 38 in both of them, well, it's going to be very frustrating because you can't actually get rid of your problem h on the bottom. The other ones are going to be similar, so I'll just go through that process. Okay, same pain at x equals 2, so I'll have to figure out f of 2. So that's negative 3 by 2 squared plus 2 times 2 minus 5. Or negative 12 plus 4 minus 5, which I believe is negative 13. F of 2 plus h, same thing. I just figured since I'm inflicting this pain on you folks, I should have to do it too. So we go through 4 plus 4h plus h squared. Again, if you're not sure, then write that 2 plus h out twice and FOIL. 4 plus 2h minus 5. Bit of a mess here. Negative 12 minus 12h minus 3h squared plus 4 plus 2h minus 5. Putting these all together, we get negative 13 minus 10h minus 3h squared. And full disclosure, I made a little goof I had to go back for. I noticed it sort of halfway through the problem, and through the magic of editing, you don't see it. But I'm still admitting it because it's easy to make small algebraic mistakes. And if that happens to you, you shouldn't think, oh, I know nothing about this differentiation thing or this slope finding thing. It's just that we made a goof. So in this case, it's going to be lim as h goes to 0 of f of 2 plus h, because it's always just the number that we care about, or the point that we're looking to find the tangent slope at. Okay, what do we get? We get negative 13 minus 10h minus 3h squared all over h minus f of 2, which is negative 13. And then we see, oh, those negative 13s, they're going to be gone, so that's helpful. If that didn't happen, we'd be in real trouble. Okay, and now we can factor to get rid of our problem, which is always what a limit's about. It's about trying to find a way around division by 0. We're answering the question, what would happen if we could? Okay, and then we get negative 10 minus 3h. Finally, we can sub in, so I'll drop my limit. 3 times 0. Oh my gosh, we get a slope of negative 10. I gotta tell you, I'm getting tired at this point, but let's do the last one. And let's do x equals 1. So I really hope that you're just not watching me do the solutions. That would be, I guess I'd be kind of impressed with your tolerance for boredom. But for anything other than curing insomnia, doing this without trying them is probably not a good plan. Now let's find f of 1 plus h. I'll try not to do any goofs here. 2 times 1 plus h minus 5. And so we have negative 3, 1 plus 2h plus h squared plus 2 plus 2h. It's worth taking second to appreciate like the elegance of the thing we're doing here. We're getting around the fact that you can't use the same point twice by saying, here are 2 points that are just infinitely close together. Okay, I get minus 4h minus 3h squared. Maybe you're getting a sense of which number really matters there. M tan at x equals 1 this time. I'm using the word slope. I can't help that. That's my North American schooling coming through. But the IB will probably use the word gradient. But then your first year calculus will probably use the word slope. So it's all good. Okay, f of 1 plus h is this monstrosity. F of 1 is negative 6. Oh my gosh, they're gone. Even though this is really elegant, in the end it's just drudgery, hey? Because you're just plugging into a formula. Sorry, there should have been an h there. It's kind of like the quadratic formula. You just get a formula and you put it in. All right, and those h's divide out. Lim as h goes to 0 of negative 4 minus 3h. Sub in 0 for h, because you can now. So minus 3 times 0. And get rid of the limit notation, because we actually have found the limit. There we go, negative 4. I want to just look at these on Desmos for 1 second. So here's this function that we've been working with this whole time, negative 3x squared plus 2x minus 5. And it's worth noting that right here, if we're at, let's see, if we're at about 1 on it, it does look like it's got a negative slope. Its point is 1, negative 6, but it's got a negative slope. It's not super steep, but it's pretty steep. So negative 4 might be a good estimate of its steepness. And in fact, it's its exact steepness. Over here, it's steeper at 2, and we found the slope at 2 was negative 10. So of course it's got a negative slope. It's moving downward, but it's steeper. And back here at negative 3, let's see if I can get this to trace. At negative 3-ish, it's very, very steep. And it's a positive slope. We found 20. So all this stuff is lining up geometrically. So if you made it through this last one, give yourself a pat on the back. Well done. You're able to find tangent slopes. Congratulations. Differential calculus is all yours. You have earned 1 second time of the sign-off. I hope this has been helpful. Good luck with the material, folks, and take care.